In this video, we will use Google Sheet and Excel functions to generate the Legendre polynomials. Begin with the values of x, which is our range from -1 to +1. This will contain our dataset of the Legendre polynomial, which we can chart, the coefficients, which uses multinomial and combina, and the value for k from 0 to n minus m using sequence. And the value of n will be data validation, list of items 0 to 10. And the value, so we have the values of n from 0 to 10. The value for m will be data validation, list of items 0 to 4, 6, save. And we'll complete the Taylor series expansion formula, which is equal to array formula series sum of the quantity x. So that's x minus 1. So x minus 1 over 2 raised to the power k, which starts from 0, incremented by 1. And the coefficient will be this range. And we'll complete that. These are two values. That's negative 0.5 to the power m. So minus 0.5 raised to the power m. That's the first part. Times another one. That's 1 minus x squared. Minus x squared. So x squared raised to the power m over 2. That's m over 2. M over 2. And we'll close that. So that completes the Taylor series expansion formula. Now we'll complete the coefficients. So this is equal to factorial m times multinomial n comma k n comma m comma k. Our k is d3. So the last part, this is times combina n minus m minus k, which is d3 plus 1 comma m plus k. So m plus d3, which is our k. As we drag this downwards, we have to lock the references. So b14 should be locked. That's a value for m. All b14 should be locked. All our m values, we lock this. And our n, that is d14. This one, we lock this. d14 should be locked. The only thing that's not locked is the d3, which moves. And we add one, and if this is empty, this should be 0. So we have another condition. If d3 is empty, then 0. Otherwise, calculate. So very good. So if we drag this downwards, that's because it's empty. 0 because it's empty. Otherwise, you'll calculate. And the value for k, which is from 0 to n minus m. So this is equal to sequence n minus m. That's the row, the number of rows, plus 1. One column starting from 0, incremented by 1. So that when n equals 2, and let's say m equals 5. So n minus 5 minus 2 equals 3. So our k values will be 0, 1, 2, 3. And we'll chart this. Insert, chart, and we scatter chart. Our trend line will be polynomial to the 10th degree. We'll use polynomial to the 10th degree. That's it. And we'll put the equation on the left and enlarge it to make it visible, like 16, font 16. So that we have here the trend line and the polynomial, the associated Legendre polynomial. So if both m and n are 0, so we have the value y equals 1. At n equals 1, that's x. And n equals 2, that's minus 0.5 plus 1.5 x squared. We'll calculate this using LINEST. To do that, we complete the 1 comma x matrix. So this is equal to array formula of the x values raised to the power 0 to 10. Now we can enter LINEST. This is equal to LINEST data y and data x. So we have the polynomial starting from 0. At n equals 0, m equals 0, so our polynomial y equals 1. At n equals 1, our polynomial y equals x. N equals 2, polynomial y equals minus 0.5 plus 1.5 x squared. That's minus 0.5 plus 1.5 x squared. N equals 3, minus 1.5x plus 2.5 x cubed. Let's say we put 2. We start with 2. And we put here 1, starting from 0. There's no data. It has to be greater than m. So we'll use 2. At m equals 2, our polynomial y is 3 minus 3x squared. That's 3 minus 3x squared. At n equals 3, it will be 15x minus 15x cubed. N equals 4, it will be minus 7.5 plus 60x squared minus 52.5 x to the 4th. We go to 4. If we go backward to 3, there's no data because it has to be greater than m. So 4, greater than or equal to. At m equals 4, n equals 4, that's 105x. 105x to the 0, so 105 minus 210x squared plus 105x to the 4th. At n equals 5, that's 945x minus 1890x cubed plus 945x to the 5th. This completes the use of Google Sheet and Excel functions, sequence, series sum, combina, and multinomial to generate the associated Legendre polynomials.